我还有一堂课，
你现在休息时间吗？
只有5分钟吧。对，I don't have time。 So this turn on, and this is recording. So let's don't let sound go on here. Yeah, don't let video go on. Alright, can you guys hear me? Yeah, since we only have a small class and I think you guys can just unmute yourself, which should be good. I think the last session I had 30 students, so if everybody unmute themselves, it was a mess. But hopefully, I think for 11 we should be good. Can you hear me, Chase? Yeah, I can hear you very good. I'm sorry I had to turn you away this morning. I feel bad. Okay. Um, did you find the video I sent you helpful? Okay. All right. Then so what problem you had eventually? What got you stuck there? Yeah. That's from chapter 3 and 2, I think. Okay. 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 Yeah, the signs are troublemakers in this class. Okay, I'm glad Dr. Tagger helped you out with that problem. Okay, so you're gonna stay on campus, Chase? Okay, and I just want to let you know, stay safe and try to reduce this, social contact with other people. It's getting serious now. Yes, so we push the homework due date on this one. Quiz will be closed. Okay. Let's see if I can change this. Problems homework 4A at its settings. Wednesday, 18th. All right, let's see. We have 9. Who are we missing here? We have Zach, Nicholas, Gina, Jack, Dayton, and Chase, Connor. I think we're missing Micah, Merk. Haven't seen Merk for a long time. Okay. All right, everyone. Let's I'll try unmute yourself too, and let's see how that works. Okay, Brandon. Yeah, I forgot Brandon. Good, I can hear you very good, Dylan. Okay. So how everybody is liking this Zoom meeting? Okay. How interesting. Oh, okay. That's yeah, that so that's something I want to let you know, guys. Um, Chuan University only has the basic membership of Zoom. So it pretty much is a free version. They didn't pay any money to this Zoom. So everybody got this basic version that can only last for 40 minutes for group meetings. So I think during during one point during our lecture, and it will interrupt and get disconnect everyone, and we have to reconnect again. Okay, Jaina, can you hear me okay? Also, Dalen K. Okay, and Zach and Gina, are you guys good? Okay, okay, yeah, okay, okay. I saw Gina's message. Okay. All right. I think that's we can just get started. Okay, so I guess this is the new form of teaching, maybe for the rest of the semester. I don't know. So far, they told me this is for 2 weeks, but I guess that's just my guess. Um, we probably will have this online teaching for the rest of the semester. Hi, Brandon. How are you? Good. All right. So I think we got most of you guys. Are you guys all on campus? Okay. Yeah, I'm not on campus. I just left. I went to a campus this morning, but I left and came back home like 2 hours ago. The reason of that because I got an email from one of my students from a different class, and his wife uh has been tested for coronavirus. So I was shocked, and I had close contact with that students during classes and office hours last week. So I better just stay home and keep it play this safe. And also, I want all of you take this seriously. It's not a joke. It's not a flu. It's something kind of scary since I have a lot of friends and relatives living in China, and they spend more than 2 months to make everything under control. And you know, China, the government spent a lot of resources and shut down, locked down all the big cities, and force people to stay home. And by doing that, they spend more than 2 months, and everybody are were forced to wearing face masks in China, but I don't see anybody wearing face masks in the States, and I can only see this coronavirus gonna getting bigger and worse in the future. So I want every all of you stay safe and keep your distance from other people, and if you can just stay in your apartment or house or stay home as stay away from others as far as you can. Um, okay, and just be prepared. The rest of semester, we probably will do this online teaching thing. All right, and that we're gonna use Zoom meeting or YouTube streaming, like I mentioned, and also I will switch all my office hours to virtual office hours through Zoom meeting. And I created a Zoom meeting for office hours on Moodle. So let me figure out a time, and then I can send out emails and let you know that's my office hour. You can click the Zoom meeting and join the office hour, ask questions. And 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 also for the quizzes and exams, and I I foresee there will be all online in the future, and if we have any. And so the initial plan is we're gonna upload a PDF version of quiz of exams. Then you can just work the exam out on a piece of paper, and once you're done in within 15 minutes, you can take pictures and then upload it to um, Moodle. Then I think that's kind of the plan. And in terms of your paper homeworks, and just you don't need to turn in any paper homeworks from now if we're doing online. So, but I would still encourage you, and I want expect you to um, have the piece of paper, write everything on paper as you're working on your problems homeworks, because I think that the process writing everything down is very beneficial for you to practice and understanding how to set up problems, and it also help you to track where was your mistakes. And so please keep doing that. It just you don't need to turn in that paper homework anymore. Just keep that for your own record. And yes, that applies to this homework. Um, uh, so I just disabled that, and so you don't have to worry about upload your or scan your paper homeworks anymore. And if you do want to get feedbacks on your paper, like how to set up problems, and feel free to scan it or send picture, um, and through send it through my email so I can take a look, give you more detailed comments. But if you don't want to get any feedbacks, then there's no need to do anything. Okay, any questions on kind of the plans for the rest of the semester? Homeworks, exams? Any question? Okay. Um, so I think most of you may have questions on this problems homework 4A, right? There are two parts, problem A and problem B. I think some of you have difficulties to get that down. That's why I extended the due date to Wednesday instead of today. So you have 2 more days to work on um, the problems homework. And also I send out 2 links, right, for the video links and for those homeworks. And those links will be really helpful for these 2 homeworks. And make sure to check it out. And if you still have questions, and feel free to email me, let me know. And like I said, I'm gonna host virtual office hours. If you send me email, let me know you have questions. I can send you a link for the Zoom meetings, and we can have a video kind of like office hours. All right. Any other questions? Just take a few minutes here and to um, let you think if you have any questions and concerns, and I will be here to answer your questions. Concerns. I just saw um, Micah join us. How are you doing, Micah? Can you hear me? You can unmute yourself and tell me. Okay, yeah, that's a thanks for bringing that out. Yeah, if you look at, let me share my screen. Can you guys see my screen? Okay, now I think you can. You guys can see my screen, right? Okay. Yep. So yeah, this link is for Dr. Tiger's section 1, and this link is for my section 2 and section 3. So make sure you go to the right links. And also the office hour links is here. So if I'm gonna host virtual office hours, I'm gonna send out email, then you can log in through this link and to join the virtual office hours. And homework for A, it's postponed, it's extended to Wednesday. Just want to let you know. And once again, since we're already here, just um, yeah, make sure you there we have a, let me see if those videos are available to you. So once each chapter is done, I will make sure I make those homework videos available to you so you can watch those videos that could help with your homework problems. And at the same time, I highly encourage you to, for example, now we're on the chapter 4. Watch all the videos under chapter 4. If you feel like chapter 4A or 4B is very challenging, and though there will be some good videos here to kind of like help clear up your confusions. Okay, any question, guys? No questions? Okay. All right. So today I'm using this Zoom video, but in the future I'm planning to do a live stream YouTube to just kind of like go through all the problem setup and stuff like that, just like what we did in class. And like I said, the reason I want to use YouTube because YouTube doesn't have that limitation that cuts you off every 40 minutes. So also it's easier to access for everyone as long as I share you the link and you can just click link get you to the YouTube video. You don't have to log into your Moodle. I think that's easier for you to access as well. So how's your thought on moving the lecture into YouTube live stream? Can you share of? Mhm. Yes, that's also that's one of the benefit. Like once the live stream is done, and it will automatically save that video on the channel. And then you can revisit that as many times as you want. Yes, so I am sending out this link for the live stream YouTube channel. That's a new YouTube channel I created. Make sure you subscribe to that channel and make me a famous YouTuber. Just joking. Um, so good, great, awesome. Thank you. Then so my plan is we probably will keep this Zoom meeting on. Oops. Okay, let me see what is going on here. Okay, I I think someone has a speaker on so I can hear my own voice because there's a delay on the streaming. So okay, I just mute Chase. That's better. Okay, so now you should see the link. Let me share my screen. Um, where's chat? Let go. Okay, where's chat? Couldn't find the chat anymore. Okay, anyway, so I just sent you a link that guides you to oops. the YouTube live stream page. Sorry about the descriptions. I use this software, the live stream software is called Omelette Arcade. It's a gaming streaming. That's why I give you automatically generate this description there. I need to edit that later. But yeah, that's the YouTube channel I created and planning to upload all the videos in the future into this channel. So, oops. So make sure you go subscribe my channel and make me a very famous YouTube by the end of semester. No, um, okay, then okay, that's a plan. So let's keep this Zoom video on, and at the same time, I would write everything on this on the live stream. Okay, there's a little bit delay, so just bear with that. Okay, we still have a little bit time today, and first thing I want to clean up some of the things in your homework. So first thing is, I think in one of your homework problems, that's problem A, I guess. What? Oh, that's stop. Um, I was. Can you just like, oops, you can just go to the link I just sent out on chat. Can you see the link on Zoom? Yeah, just click that link. That will get you to the YouTube window. Yeah, so probably um maybe let's see. Let me mute my Zoom to make it better. Okay, if you can hear me good, and just reply that either on Zoom or on the YouTube. No, there should be no echo. Can you guys hear me? Okay, good. All right, let's do a quick recall on the 6 steps approach. There's a little bit delay, but I think it would be okay. So we're pretty familiar with step 1 to 2, right? You draw the free body diagrams and set up your coordinate systems. For example, on one of your homeworks, you have 2 blocks. One is called A, that's hanging with a polar. Another one is hanging on a slope, something like that. Let's call this B. So when you have 2 mass, make sure you have 2 free body diagrams. One free body diagrams is for A, another free body diagrams for B. So you have 2 set of free body diagrams. One goes like WA, TA. Another one has different orientation as WB, MB, TB. Yeah. And step 2 is give a coordinate system for different free body diagrams. So I would see some of you will use this just straight up and horizontal direction for A, right? For J and I, and that makes sense. And some of you may use a angled I and J for B. Yeah, that's totally okay. Just make sure because this two coordinate system has different angle. So what I would suggest you to do is I would make sure I make them different. So this is I will say IA, JA, and on this side we have IB, JB. So in this way, you're telling yourself you have free body diagrams in two different coordinate systems. And then when you do step 3, let's change color here. Black. When you do step 3, you need to write down all the forces for both A and B. So you would write forces for A that has TA equals TA positive JA direction. So make sure you add that JA on. And you have WA that is on WA negative JA direction. And this just for A. Then you need to write down your equations for the vector form forces for B as well. So you have TB that is on the negative I direction. So it's negative TBI. Sorry, someone is asking questions. Oops. So WB equals then in this case you need to resolve WB into both IB and IA. And similarly for N, it's pretty easy. That's on positive JB direction. That's positive JB. Okay. So once now you know you have two different set of coordinate systems, and make sure you don't mix them up, because we need to step 4. That's for your accelerations here, AA and AB. And I will just skip that and to step 5. Yeah. Yeah, that's a good question. Since what I draw here is a little bit different from the homework, I just want to give you a kind of clear the concepts. And I will explain that later once I finish step 5. So step 5, when you need to use I sum of forces equals MA, then you will realize once you substitute all those forces here, 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 they all have different coordinate system inside of once you substitute into F. And you need to make sure you do the conversions between these two coordinate systems. This one, by using the angle, do the conversions if you want to kind of like combine all the J terms and the I terms. So I think that's something you may have questions of, is to make sure you can have free body diagrams and equations for forces under different coordinate systems for different mass. However, when you try to combine them in this step, you need to make sure they're under same coordinate systems. And in this problem, step 6, you would need step 6 to solve this one, because there's a relationship between AA and AB here. So if you look at the problem, you have A and B. They're here, I simplified it just with one rope. They're attached with this rope. And that's actually the rope problem from chapter, forgot 2 or 3. That's from chapter 2 or chapter 3. The rope problem. Do you remember how we did the rope problem in chapter 2 and 3? And in the row problems, you actually need to write down all the length, right? Something, the total length, oops, why is not? Total length of the rope equals something plus something plus some constant. Hopefully you still remember that. Then you take the one dot, single dot on both sides of the equation, you end up with something VA plus something VB on the other side. If you take the double dot, you end up with acceleration of A plus something acceleration of B. That's something we did in chapter, I forgot which chapter, 2 or 3. If you apply that to your to this rope problem on your homework, and you will get a relationship between AA and AB. Actually, I think I don't remember which one is, but A and AB has 2 times. So one of the acceleration equals 2 times of another one. You need to look up your homework problems and do the analysis from chapter 2 and chapter 3 to get a relationship between AA and AB. Once you have that AA and AB, then you can get rid of one of the unknowns inside of this F equals MA problem, if that makes sense. So you need to have those pieces in order to solve this homework problem. And another homework problem thing, it's about there's a T-bone shaped tube and with a particle inside. I think on this end is fixed, rotating about this point, and there's particle can go either up and down inside of a tube. I think that's something on your homework. For this homework, you need to refer to the in-class example we did. Let me double check which example problem. I believe it's 4A10. Yes. So for that problem, refer to the example. All right, by the way, the Zoom will be we're just end everybody, disconnect everybody in like about 5 minutes because the 40 minutes limit it's up. So how about we have 22 minutes? How about everybody just like disconnect this meeting and reconnect so it won't interrupt. Okay, let's stop here then. Just like end meetings. Yeah, but I think the keep going. Okay. Oh, okay. Okay. Either refresh or just drag that time bar to the. Okay. All right, let's keep going. So that homework problem, I think, is problem B. That's the echoes going on. All right. Okay, so refer that homework problem to 4AB, 4A10. We did that homework in class. If you still remember, we did two different approach. We used polar coordinate system for that particle P, and another approach we did is oh, what we did there. We used polar. Who can remind me what we did in class for different approach? Got blackout. Oh, yep. Yeah, so for that's approach one, use polar. And the second approach we used is the moving reference frame from chapter 3. In that case, you need to set up your observer, like a observer, like the small peep on the bar. So you're standing there and looking at how that particle P is moving, either towards you or far away from you. So in that homework problem, you do need to use consider the moving reference frame from chapter 3 to solve that homework problem. I think that's if you don't remember how to do that, I want you to review your lecture notes on 4A10, or you can go to Moodle to watch the video how to solve that example problem. I think those are the homework problems. And I want to save some time for the new sections, so I'll just stop there. If you have more questions, we can talk maybe after this lecture. Okay, so now we're done with 4A. We're done with that. We're moving to 4B. Okay. In 4B, we will use a totally new method, which is called work and energy equation. And it's a very useful equation to deal with forces and the kinetic, like velocities, in this chapter, the particle kinetics. So let's take a look. Let's see where this work equation come from. See, inside of 4A, all we did was to analyze this F equals AM. All vectors. Yep. And Newton's second law. That's what we did in 4A. And if we look at a particle that is moving inside of a polar coordinate system, if a particle is in polar coordinate system, what is the expression for this acceleration A terms? Do you still remember the equations for acceleration under polar coordinates? Sorry, not polar. Let's change that. Change it to path. Let's talking about path. So the acceleration under path coordinate system has two components, right? V dot et hat plus v squared over rho en hat. We learned about that very in the early of the semester. There's a dot here. Let me change this. Remind yourself of that equation since we're gonna use that. Okay, so this expression for acceleration for path, and when you look at the first term, the et hat and en hat, et hat is on the tangential direction, right? That term also has a name. Hopefully you still remember that. It's called the rate of change of speed. and it was on one of your quiz and exam, I believe. So that tells you this term of acceleration only responsible for how fast the speed is changing. So it only controls the change of speed. And however, this term, the E hat n term, that term does not has nothing to do with how fast the velocity of speed would change. This term is related to direction only. This term is related to speed. So that tells you on the tangential direction, it's only in charge of speed. On the normal direction, only in charge of direction. So make sure you understand that. So in the work and energy equation, what the forces we care about, it's only the forces that can change the speed of a particle. So we only care about the force that changes the speed of the particle. Therefore, from this acceleration equation, we only care about the direction on et hat direction. And in order to get out that equation, we want to use the dot product, which is a projection we learned, we encountered a long time ago. It was on your textbook page 11. So we can take a dot product on both sides of the equation with this et hat. So dot et hat on right side and also dot et hat. Oops. Let's just replace this f et hat. Now once you dot product this et hat on both sides equation, you can have a new expression for forces and the velocities. So you end up with forces times et hat that equals m. We substitute a with that new expression with a past coordinate system. That is m equals v dot et hat plus v squared over rho en hat, and dot this et hat. So the only thing we has changed is that we dot product this term on both sides of the equation. So nothing, so it's still equal because you can cancel it off. It will be equals to what we had there. So keep that in mind. Okay, once we have that, let's look at how would that dot et will affect this everything. It won't do anything on this side of the equation, so it's still the same. But on the right side of the equation, et hat dot product et hat will give you what? Will give you 1. So if the dot product between two same unit vectors, the result is 1. So you end up with v dot, just v dot, plus, but however et dot product en, because this two unit vector has 90-degree angles in between, right? That's what we learned under path coordinate system. They always perpendicular to each other, so the dot product between them is 0. So this whole term goes to 0. We end up with this. So simplify this is mv dot. On this set of equations, sum of the forces dot et hat equals mv dot. And now we can do some tricks. What is v dot? V dot, it's a derivative of velocity with respect to time, right? So we can write it up Vt v dv over dt. And then we can keep applying the chain rule to expand this. We can add a middle term, dv over ds times ds over dt. Do you see the transformation from here to here? The only thing difference if we add this intermediate term ds. This ds can cancel off each other, and you have the same. You will end up with something. You will end up with the same thing here. So this is just ds can be canceled off. But we do need that because if you look at this, if you look at this term here, what is ds over dt? ds over dt is actually v, right? You take the derivative of distance with respect to time. The first derivative of distance will give you speed. So this whole term goes to mv dv ds. Yeah. So now we have something interesting here. On the up, let's removing this term down, f dot product et. That equals to mv dv ds. Is everybody okay right now? Okay. So now we have this term. We can throw this ds to the other side of the equation. So that we times ds on both sides of the equation. Then you will get sum of the forces et hat ds equals mv dv. All right, so we can do something now. Since on both sides of the equation, on left side we have ds, on right side we have dv. We can take the integral on both sides of the equation. This. Okay. And then on the right side of the equation will become, you solve that integral, then you will end up with m times v2 squared over 2 minus v1 over 2 squared. On the other side of the equation is integral of the forces times et hat ds as distance. So that actually tells something quite useful here, because we can define u1, 2, 2. That's a work. That means the work done from position 1 to 2. That equals the integral of the forces times et hat ds. So that is work done from position 1 to position 1, from position 1 to position 2, 1 to position 2. That's also called the change of kinetic energy. Oops, no. Yep, that whole thing, the work done from position 1 to 2 equals to the change of kinetic energy. The change of kinetic energy is T2 minus T1. That is change of kinetic energy. Oops, I couldn't spell energy. Yep. And that T2 minus T1 equals the mv v2 square over 2 minus mv1 square over 2. And actually this, let's combine this, u1, 2, 2, that equals T2 minus T1. This equation is the work energy equation. Okay. So, and this is a very useful equation to help you solve a lot of complex questions in dynamics. And we have 4 minutes left. Okay. So I want you to just look at this equation. We can have a little discussion here. If you look at that equation and compare that with, for example, the F equals ma equation we had earlier on, do you see any difference? Okay, oops. So F equals ma. If you look at the F equals ma equation, both forces and acceleration, has this symbol, which means it's a vector. They are vectors, right? However, once we dot product F equals am with that unit vector et hat, what actually it does is it transfers this vector equation into a scalar equation. Because when you look at this mv squared over 2 and mv1 squared over 2, v here in this equation, in this change of kinetic energy equation, they are both scalars. Do you see that? I don't have that vector notation on the top overhead, right? They're scalars. And similarly, when this integral here can be simplified to force times the distance, and they're both scalars. So there's no directions, they're just numbers. So the first three chapters I've been talking about, make sure you need to have a vector form inside of your equation. But now we're starting to see something different. This work energy equation uses scalar form to solve the kinetic problems. And we're gonna spend more time on Wednesday to go through this work energy equation, but I think this will be the starting points. Get you started for later 4B section. Okay, I would stop here, and if you have any questions, I will leave this Zoom meeting on so you can unmute yourself and talk to me. And then that's all for today. And Wednesday, Friday, same time, we're gonna do this with the YouTube live stream. All right, let me know if you have any questions. Yes. So let's divide this. Yeah, that's 1 to 2. From position 1 to position 2. Yeah, sorry about my handwriting. I think we're getting better later on once I have more practice on writing on iPad. That's a very good point. Yes. So if I write U122, then you have to write T2 first, then T1. So that the order matters here. Yeah, we will go through more examples. Um, Later on this week, you will see that the order of one position 1, 2 does matter in this work energy equation. If you guys have any feedback on this YouTube live stream, let me know. Feel free to send an email. Let me know if there's anything I can improve, help you to get through this master with under this very special um, coronavirus condition. And everybody stay safe. And if you don't have more questions, I will see you on Wednesday.